And I'm gonna bang the gong. I'm gonna bang the gavel. Okay. Oh, are we started? Okay.
We started.
All right. Thomas, switch the spotlight if you would. You're gonna do it? Okay, go ahead. Head in orbit.
Who's supposed to have spotlight?
I thought Dan was gonna introduce or was gonna start this thing off. Maybe I should start this thing off.
All right, yeah, you start.
All right, spotlight me, please. All right, let's see here. Good evening, everybody. Homebrew Robotics Club, May 29th. Very excited to have Chuck Pitzer is going to be our speaker this evening. He's a mechanical engineer's engineer and a roboticist. Let's see here. We'll start this meeting off with industry news. Industry news. Does anybody have any particular industry news they'd like to talk about or mention?
GPT-4o.
Say what?
GPT-4o Omni. GPT-4 Omni has just been released.
Okay, tell us about GPT-4o, Thomas, and take the spotlight off of me.
Take the spotlight off of you and put it on me, huh?
Well, just let it go to speaker.
Sure. So GPT-4o was announced about a week or so ago, and it has a lot of new fun features. For example, you can interrupt it. It can speak and you can interrupt its speech. Also, it has real-time video uploading. So you can show it a picture of a puppy, let's say, and it will react. It has several different voices. It reacts with emotion. It can detect emotion. And if it's as good as they say it is, we now have Rosie the robot and Lieutenant Commander Data all just waiting for the perfect robot body.
Is that a question from In Orbit?
I didn't hear that. Yeah.
Okay, we hear some discussion. Is that going on at In Orbit?
I'm going to mute everyone, Camp, except for supposed to be talking.
All right, thank you.
That's coming from Tuckler, which is probably In Orbit, I guess.
Okay, somebody asked me a question.
So we're all squared away.
Okay, fair enough. All right. So the news is ChatGPT 4o. That's O as in Oscar, right?
Omni.
Okay. What the point is, it's not zero.
It's
Can you put a link in the chat when you get a chance regarding that?
I will do that.
Okay. And also, can you enable screen sharing? Hey, Sam.
Hey, Camp. How's it going?
It's going okay so far. I had the Tally HBRC at 7 p.m. Eastern time. So now we got the Valley HBRC. Also in the news, the $16,000 humanoid robot. There's a lot of talk about that in the chat. You too can own a short king humanoid robot, Unitree. I put a link in the chat.
Did any of you guys ever actually try to buy it? So the reason why I ask is we actually tried to buy it. And it was kind of like weird where we were asked like kind of like I forget what Chris was saying, but it was almost as if it was like asking for his like social insurance number and like kind of like trying to verify who he was to even purchase it. And he was saying that he couldn't use credit cards. It was like really strange. I don't know if anyone else kind of like tried to actually buy it.
I think Tony wanted to rent it.
I think he
I'm,
was saying too, it wasn't like aluminum. It's like it looks like it's aluminum, but it was kind of like plastic 3D printed parts. I'm not sure if that's true or not, but I mean 16K for a humanoid robot, that's like even if it was like 10 times the price, like 160K, that's still like an insane deal.
yeah, but I mean, you got to be able to get it, and it is pretty cool.
They say it comes without hands for that price. No hands. I don't think it includes software.
Anyways, there's a link in the chat there. Is there any more industry news anybody want to bring out, talk about?
You want to see the Omni ChatGPT? I got a video I pulled up.
Okay.
Are you seeing my screen?
Yes.
Here it goes.
Introduce you to somebody.
Well, hello there, cutie. What's your name, little fluffball?
This is Bowser.
Well, hello, Bowser. Aren't you just the most adorable little thing?
Yeah.
Look at you enjoy.
This is one of his favorite things to do.
Oh, well, I can see why. Look at that focus. Fetching balls is serious business for Bowser.
That's it.
What did we just see, Thomas?
I'm sorry, repeat.
What did we just see?
You just saw OpenAI's GPT for Omni, looking at a dog, recognizing the dog, and commenting on the dog in real time.
Allegedly,
All right.
yes.
Was that a comment from In Orbit?
That was a comment from Tony, yes.
Yeah,
So this, yeah, it's me, it's Tony. Where's the mic? Yeah, so this could be one of OpenAI's numerous faked demos, but generally they haven't released the voice thing yet. They stole a famous actress's voice to make the voice thing and then denied they did that. Woohoo, OpenAI.
all right. Any more industry news? All right. Let's move on into club news now. I'm going to put the HPRC mailing list in the chat here. Everybody knows where the mailing list is. And I'll also put a link to our chat. It's a really good chat here in the robotics. Or if you have questions, these are the folks to ask your questions to. So next month is challenge month. So you have a presentation to give. I'll be bugging you all month long. I'll be talking to myself, okay, but you know, it's like next month the idea is that we want at least 20 homebrewed robots to go around for show and tell. And everybody show us what you're working on. This is a builders club. You should be building something. Our stock in trade is functioning robots works in progress are good for partial credit. Okay. So June is challenge month, phase 2. Let's see. Thomas, you've got your voice intelligence group. You're meeting weekly now on Thursdays, right?
That's right, tomorrow night.
Okay, so there's a voice intelligence group that meets on Thursdays. The link is provided in the mailing list. The Ross discussion group is on Tuesdays. The meetings on the mailing list. Now, and Stephen asked during the Ross discussion group, it's like, is there a general robotics group? Yes, the general robotics group is the Builders SIG, which is the penultimate Wednesday. So, you know, if you're building robots and you just want to get together and talk to guys building robots, not necessarily Ross or AI related, you know, come to the Builders SIG on penultimate. And that link is in the mailing list. That link is on our website. Club. Maker Faire is coming up. Tom, Marco, you want to say something about Maker Faire? Spotlight in orbit.
So yeah, Maker Faire is coming up. I send in a request to participate again. Let's see what they say. I don't expect anything until August or something like that. Last year they were very slow, or everything was kind of squished together.
Get in the camera, Marco. There we go. There we go. That's fine. That's good. Marco Walthall, ladies and gentlemen.
And yeah, let's
The
see.
RoboStar.
In October at Mare Island. So yeah, one weekend. Let's see. That's all
Very
I know
fine.
right
Thank
now.
you. More on the mailing list. Also, I think Ralph has got a spot at the park, Baylands Park, I think it is in Sunnyvale, for Botnik. That'll be a Robo Magellan event. I think he's set that for July. So, you know, get your Robo Magellan robots running.
Is that again? Or wait, what is that again? Sorry.
Is Ralph there?
Ralph couldn't make it tonight. Ralph has set up the last couple of years a Robo Magellan contest in a park nearby. Right? Yeah, I think it's called Baylands. It's, yeah, just off 101. I don't remember the date though. Does anybody have the date, or can you look it up here?
Sometime September.
September, I thought, yeah.
Okay. Very fine. So get those Robo Magellan robots. Very, very cool. Any sign of Chuck Pitzer yet?
Hey, yeah,
Yeah, Chuck's here.
I've been here the whole time, Cam.
I even mentioned him to you, Chuck. I mean,
What, me
yeah.
panic?
So are we ready for the presentation or not?
No. We got more to go. We got more to go. Let's see. What I need help with. Anybody need help with anything in particular?
It
Yeah,
was
go
just
sit
that.
down, Chuck.
I
Anybody need help?
have a quick question. Okay, so one of my kind of assignments is I want to run multiple turtle bots off of one map server, like we'll call it like a fleet. Has anyone in here tried that or have any experience with like the Nav2 stack? You know, basically I want to run one server, like kind of like a master. It will provide the map, and then each robot has to localize to that map, and you know, basically send me its like XY or something like that, which will go onto my, you know, kind of be visualized on my like, you know, kind of master laptop.
Crickets.
Yeah, looks like I'm on my own. All right, pioneering it is.
This is that's Sam with ClearPath out there. So, but you want to do one map server, and then the swarm or assemblage of robots, if you will, deal with different parts of the map.
Yeah, like I kind of want to have like an overlord kind of computer that will, send out map commands, and then kind of like a fleet manager, and the robots will, listen to that and localize and still handle everything on their end in terms of like localization. And just report back their kind of like, estimates and maybe map
Sounds
paths.
like
So hang on for a second, Camp. Tony wanted to add a comment.
Yeah, so there's gonna be two ways you can do this. One will be to try to create a shared multi-agent planner. So basically you have one nav stack and one map with all robots in it. I'm not sure if ROS Nav 2 supports that. The other option is to namespace all the robots most likely, and then have a shared map server. And the third option is just to have them all separate and use like in orbit to beam up all the data from them.
Okay, sweet. Like I think I was gonna move to the namespace kind of route. But yeah, maybe I'll talk to you offline to kind of see what, get a little more detail.
Yeah, another thing you could do is post the issue to the forum and see if you get some good comments that way.
What else? Anybody need help with something particular? I'm always needing help with the scan topic disappearing when I launch Slam Toolbox, but everybody knows about that. Anything else? All right, let's move into show and tell. We got anything for show and tell this evening? We got anything at show and tell in orbit?
Anybody bring a robot show?
Robot, I do a little like compute robot sort of board.
We have one show and tell in orbit. If you're ready for Camp, are you?
Yes.
Come on up. Use this table, then the camera will be pointed at you.
All right, look at that. All right, so.
Hey, Nathan.
So, hey, Cam. So the last month, I've mostly been playing around with whatever NPU like quote AI enabled devices I could find. So I've been trying to, I guess, so in general, most of like the NPU enabled like ARM boards and things that are out there, like a lot of them have like a price for like $50 or plus. Like there's like this I think the company's called Redaxa. Like they have this thing called the 03W, which is kind of like a Pi Zero, but it's faster and it has an NPU, but it's a question mark on whether your board will actually have it because they don't officially have it on their feature matrix, and some of the chips have some. Either way, so I found this RISC-V board. Like I've been seeing ads for a couple of months like for it. It's called like the Milk 5 Duo or something. But one of the advertised features is it actually has an NPU on it, and it's not like a super fast one, but it's also not too slow either. It's like 1 teraops, so it's not super fast, but it is enough to run like one of the smaller object classifiers in real time. So I have this little, so I have it with me. I will point my laptop at the but we've got this camera test application.
Standing down for you.
Camera test app we can run. So this is actually basically, okay, here we go. So this is just running okay. The video froze. I thought the board would crash, but no, the Zoom crashed. Okay.
So this RISC-V board's running that camera.
So it's running a camera, and it's also running a face recognition model at 30 FPS, like on the NPU on this board. And probably the killer thing about this board is it costs like $8. So, and the camera costs like $3 if you're willing to wait 2 weeks to get it from AliExpress or something.
So
but like, yeah.
is it USB out?
So there's a USB 2 on the go. So in this like scenario, it's just like USB Ethernet, like it's emulating Ethernet over USB. If you like, you could also like plug just a simple USB-C adapter and like put flash drive or Arduino or whatever in it. And so, but the cool thing, I guess, is that it's Pico like form factor esque, and there's a singular big RISC 5 core in it, so it's not the fastest thing in the world. So it does have onboard video encode that can get the video out of it. The NPU's on board, but it's like a single like 1 gigahertz like RISC 5 core. At least it has vector extensions, and then there's a second RISC 5 core that doesn't have an MMU on it, so you can run like an Arduino sketch like on a second core that's in here. So, and then there's like mailbox registers to talk between like the Linux side and the like Arduino side. But yeah, for like $8, it's cool to actually have like an NPU. So I'm working on trying to get that like orange cone model that I found earlier in the month running on here, because they actually do have in their SDK, they do have support for the version of YOLO that was trained on. So I'm trying to figure out the cheapest way of building a cone finding camera for.
Does that have like a micro SD board or something? Is it
Yes,
Linux?
so there's a little micro SD. So it's I'll point it to the camera. There's a little micro SD card like holder on the back of it.
Okay, so it's actually running Linux.
It's actually running Linux, yes. So, but it has 1 core. So it's not fast, but the whole idea is just to offload everything to the various little accelerators that are on the chip.
Can you upload the part number onto the?
I will put I will send on the mailing list. Yeah. And the reason I wanted to bring it because the NPU demo has been broken until the day before yesterday. So they finally posted NPU support the day before yesterday. So last night I was like, it works. Let's go.
Or we have, Cam, we have one more demo in route.
Go for
it. Turn.
Go for it.
Okay, just 1 second. Oh. This is the mic and camera.
Okay.
Hey, Dan.
Hey, Camp, how you doing?
Doing well.
Most of you have seen this particular robot. It has been around for a very, very long time.
RoboNova.
Yeah, RoboNova, built in 2006. That's not what we're demoing here, really. Originally, this came with an IR controller, but in 2006, Dave Calkins asked me to do something a little less primitive because the same IR controller controlled all the robots, and we wanted to play soccer. So we took a PlayStation controller, cut the cord off, built a little PIC board with a Zigbee adapter on it. We put a Zigbee adapter in the head, and we ran it for years. And then it got kind of cumbersome to run joysticks and buttons. So I created a Windows app, which was the easiest at the time with Microsoft Studio. And I was able to do push buttons and everything using the same Zigbee. Ultimately, getting devices with Zigbee was a problem. We had to have USB connectors on them and everything. So for Robo Games this year, I threw away the Zigbee. I bought these little things from China. They're little Bluetooth adapters to serial. They're very easy to interface, and I plugged them in. I had to build a little voltage drop from 5 volts to 3.3, and then because it didn't come with a regular. You can buy them in regular. And I plugged it in, and then I wrote an app it runs on Android, Windows, Linux, it runs on everything. VisualStudio.net now. So let's see, yeah, so I don't know. Can you see that?
Yes.
Yes. Okay, so that's the app, and it might already, let's turn it on. Let's turn it on. Let's change the battery. Oh, there we go. Okay. And then I may have to connect it, I may not. Bluetooth, and say connect. We'll find each one I renamed for the robot. This one's RoboNova 42. As indicated with the numbers. I couldn't figure a way of filtering out just by name. So I just choose it out of the list. Oops. So we can go out, and then let's see, Kung Fu, and then I don't know, this shows you all the Kung Fu moves that are on there. And let's see if we can just do a left turn. And so that controls that. And then ultimately, I had him doing the stair climb for the competition at Robo Games. I won the gold because this was the only guy that could walk up and down the steps. And I programmed it in about 3 hours, which was really amazing that I got it done. But the important thing is the .NET app. If you want to do something really easy, the code, I'll send you the code. You can just use it as a template if you want to run something on your phone and you want to run a Bluetooth and you want little push buttons and stuff to run it. And that's my demo. Yeah, I guess we can do a, let's see if we can do a left.
Wow. Wow.
Whoop, his battery's probably a little weak. I brought extra batteries, but, and then, let's see, you can do a forward punch. Whoop. Well, so much for that. Let's try a,
That's awesome.
let's try a tumble. Let's see if that works. So that's the kind of stuff. This is nothing new. Yes, right. Okay, thank you.
It's awesome, Dan. Big round of applause.
Yeah.
Are you not entertained? All right.
Do we have any demos in the room? If not, we'll throw it to you, Camp.
Thank you. Any demos online?
I don't have a demo,
have
but kind of like a
something
quick
that-
little hack that I did. It's just really to get the Turtlebot to kind of power on. I just paired it with one of those Alexa smart plugs, and actually works beautifully. I have it on a schedule, so the robot wakes up at 8. It goes back to its dock at 11, and it charges for an hour after that, and then the dock will power down along with the Create 3 base. And it's just like a cute little hack. Works great.
Did you want to show it?
I don't I don't have it kind of like for like
Okay, yeah, that's
to
okay. That's
show, but
okay.
it's just kind of like the concept of it.
Yeah, that's fine. Somebody else had a show and tell in online?
I do.
Okay. Hey, Thomas, can you unspotlight the in orbit?
Okay, I'm going to share my screen here.
All right, Dilla, go for it.
Ugh, keeps double clicking. Okay, so let me also start my video here. There we go. Okay, so I've been working on kind of a new power system for my rover for Tenacity. The batteries, like the RC batteries and the wiring and the plugging and unplugging and everything, and just like the bring up time. This is all part of my work on like reducing the bring up time of the rover. So I think somebody from the club here, I forget who, but somebody from the club here turned me on to I'm going to share my screen. Share. Okay, somebody from the club turned me on to these battery modules from a company called Parts Express that does they're mostly like an audiophile site, but they do have these battery packs that are meant to, like, I guess, power a portable speaker or something, but they're just it's a 18650 batteries with a bunch of outputs and a barrel jack for charging, and you can plug in a solar panel, and they've got like the if anybody worked with the Turtlebot 2 and you had like those connectors, those specific connectors on the back for like charging your laptop and things, it's got those as well. So I've been building this in OpenSCAD, and I just finally got to the point where I was able to print out like the full-size case. And so what what I wanted to show was this is what the robot looks like right now with the RC car battery sort of Velcro strapped to it. And there's kind of wires hanging out, and I have to hook them and unhook them. And it's kind of a pain in the butt. And I've been a little bit maybe I don't know if I would say somewhere between jealous and inspired by some of the other kind of production rovers out there that just use a barrel jack to you plug it in and the thing lights up.
Those are 7.4 volt packs, aren't they?
That's the 7.4 volt, and then there's an 11.1 in the back. So the 7.4 drives the motors, and the 11.1 gets boosted to 12 for the dynamixels, and then it also gets like converted back down for 5 volts for the Raspberry Pi and for everything else. So it's also a little bit complicated. So that's kind of what it looks like now. This right here is what it's going to look like in the not too distant future. So all the cabling and the wiring is gone. I've got like these, room for 2 battery modules in here. There's this thing in the back, which provides a barrel jack to charge off of, and also 2 5-volt USB charging plugs. So you could plug 2 USB, like I could plug in a voltage boost for the Oak D into that. That's kind of like what it looks like overhead. And
what are those 2 boards on top, Stephen?
What?
What are those 2? What are those 2 boards? It's the battery.
Those are the battery charging boards that I'm talking about.
I got you. Okay.
So this replaces the RC car batteries and all of the cabling and like the Dean's plugs and everything like that, and the Dean's plugs to the Tamiya adapter and just all of that mess with this barrel jack right here. And there are 3 18650 batteries in each one of these. So I think it just cleans up the top part of the rover and even like the insides a bit, because
let me understand, you've got those 2 battery packs in there and you're plugging in a jack to charge those.
Yeah, now all I have to do is just plug in like a wall wart to charge it.
Okay, and your wall warts, how many volts?
The wall wart is 12.
Okay, so this thing's doing the balancing and the checking and yada yada.
Yeah.
It sounds a little alarm or a buzzer when it's done or something.
Yeah.
Okay.
And it does it all by itself. You don't have to hook in like the balance cable. And then
the balancer, it's all plugged in.
It's all
You're
plugged
just supplying
in.
the voltage, yeah.
Yeah. So it's kind of a lot more just, professional. It's a lot cleaner than this.
Are those 2 packs the same? They look different.
No, one is 12 volts and one is 7. One is 11.1.
That's different than the other one.
And one's 7.4. And what I get with this thing back here is that down converts to 5 volts. So I get 12 volts, and then I get 5, and then I'm probably, for the motors will actually work at 12. They work better at 6, but they will work at 12. So this is just a much simpler solution. And it's all in a 3D printed case.
Okay. But these have those cells in them. This has those fat cells. Fat A.
Yeah.
It's got the fat A cells separate and distinct from your RC car batteries.
Right.
Okay, so you charge those separately still, right?
Well, you plug in like the barrel jack connector into the back, and you
can charge your RC car batteries with those too?
No. The point is to get rid of the RC car batteries.
Gotcha. Okay, so okay, I get you now. You're weeding out the RC car batteries. Okay, thank you.
Yeah, and it just makes it a lot cleaner, and it looks. I mean, I don't know. I think this looks nicer.
That's very
Um,
interesting. Can you post?
the
Can you post to the mailing list a link for
I
those
did.
factory specs? Okay, very good.
I
Thank
did.
you. All right.
So this is so I'm going to stop sharing that, and I'm going to come over here and share what?
Okay, we need to get to the presentation, but go
Yeah,
ahead.
yeah, I know. This will just be another second. Okay, so I'm going to share that really quick here. So this is what the 3D print looks like. So you've got that deck there that you saw, and then you've got the case. And
You're doing that with FreeCAD?
no, OpenSCAD.
OpenSCAD? Okay.
Yeah.
Very good.
So, you know, you can see where like the posts where the batteries go.
Very
and
good.
then you've got this thing on the back with the barrel jack and the USB.
And you 3D printed it.
And yeah, I've 3D printed at least like one revision.
Super, super. All right.
So that's basically it. That's kind
Very
of what
good.
I've been working on. It's
Thank you very
nothing,
much.
you know, kind of like a lot of my stuff. It's nothing like super sexy, but it's nothing like, you know, it's not a fancy algorithm or anything, but it's
sexy enough.
it's practical.
All right.
Sexy in a practical way.
All right. All right. Moving right along. All right. Are there any other show and tell quick? We're done. Any more show and tell?
I've got a real quick one here. I think
All
I
right, real
can
quick,
get it.
George.
Okay, let's see if I can get let's see, I need to do a share here. It's only take a couple of seconds here. Remember back in October, we had the VIM presentation. Yeah. Okay, so I have been working off and on trying to do something with that. So here's a, let's see if I can get it where you can see it. Here's a stepper motor that's set up, and I'm actually controlling the stepper motor from Manhattan. And when it runs, I command it, and the commands go to New York from the internet to the server there. And then it causes, you can see the stepper motor. I don't know if you see enough of it.
We're seeing
this is the setup. I got this at the flea market. It's a pretty nice setup. And then there's a Raspberry Pi. I had to do a level conversion here to protect the Raspberry Pi. But anyway, I've got it working, and believe me, dealing with that VIM stuff is a lot more complicated than they would lead you to believe.
Are we talking about voice control? Is that when you mean you say VIM?
No. Remember the VIM presentation that we had in October?
I clearly don't. What is VIM? Refresh my memory.
It's VIM.
VIAM.
VIAM. I'm sorry. Yeah.
Oh, okay. The guy in New York. VM.
Yeah, in New York.
They've just joined the Open Source Robotics Foundation too. So you're talking about VIM, VIAM. I got you.
Yeah,
okay,
VIAM. Cool. You're right. Anyway,
okay.
I've been playing with that thing, and like really tell you, it's a lot more complicated than they led you to believe on that presentation.
They suckered you in, huh? Okay, very good. Nothing's easy, especially in robotics.
It wouldn't be fun if.
Mike?
Yeah.
All right. Okay, very fine. Let's get going here because we've got a very exciting presentation this evening. Chuck Pitzer, a mechanical engineer's engineer. Contrary to popular belief, not everyone is a mechanical engineer. We went through Chuck and I went through some tight spots at NITO, but we saw our way through. Chuck's fought in BattleBots for years as the Ghost Raptor. And without any further ado, here's Chuck Pitzer, hobby project to industrial grade safety rated systems for the technology you already understand. Chuck Pitzer, ladies and gentlemen.
Yay! Thomas, can you pin on the Dan Tuckler screen? Oh, there it is. Right.
So before we get started, I want to do my show.
There's one thing about Chuck Pitzer, folks, is you don't have to be good looking, but it doesn't hurt.
Shut up, Cam. You're too kind. Keep it coming. Stop, dude.
So up like a tabletop.
Can anybody do this? Because the cool part about this robot is the sound. Nobody can.
Oh, is that like the yellow drum machine?
It is, exactly. That's where I got the inspiration. But instead of using a pick, I use an Arduino with a motor shield.
Yeah, I tried building one of those like 10 years ago, and actually longer. I think like earlier, like maybe 15 years ago, and I didn't get very far, but I should probably do it again. I would be better at it now.
Reshare the video and optimize for sound.
So yeah, I mean, if I could get this set up with sound, maybe I'll just bring it in next time.
Try it again.
Yeah, but whatever the case, it's the most fascinating thing because the way you can set up, the songs in there is you just use like it's all bitwise, right? So you're mapping out your hi-hat, your bass, and your drum, and then you layer in. You can layer in, and the cool thing about it was you would layer in a sample, right? So it would do an initial beat, sample that, use that as a layer, and then run that on repeat, and then layer in over it.
There are a bunch of like little like MIDI sound noisemaker sequencer things now. It's like there's like a whole subcategory on Crowd Supply. It'd be kind of neat to integrate that.
Yeah, I think there's better ways to go about it because you could, that required an Arduino, and you put a motor shield on there, and then you have to do a bunch of little hacks to make it work. I think it would be a lot nicer to have a custom-made board to do that one.
So when we get into the presentation now, let's hold questions and comments to the end, okay?
Sure.
Okay, yeah, I mean, if you want to ask questions, this is not a real formal presentation. So what I'm going to do is relate to you challenges that I experience because I'm a dyed-in-the-wool hardware person. So I do hardware, dabble in software. I have to understand software, but by no means can I make a living doing software. I leave it for most of you guys. But, so camp, when I first moved to the Valley, and it was October 2013, camp invited me to just show up. I did a little show and tell that first club meeting. And, it's been a kind of a long road, and things that I've learned over the past 10 years, especially when it comes to making a product, I think can be really valuable. Maybe you're thinking about making a product, maybe you're just going to stick in the hobby world. I would not say that sticking in the hobby world is your worst decision because once you get into the professional world, it's a lot harder. Making a product that is reliable, that meets all the regulatory, that meets functional safety, that is a viable product to start with, that people actually want. That's its own. I don't deal with those challenges usually. I usually deal with the challenge of here's my product requirements, and here's the spec, and then I got to deliver on that, right? And what I want to talk about, and I'm hoping there's somebody in here, at least one person in this room, get something valuable out of this that they can then use and say, okay, well, these are the kind of steps I got to take in order to put this thing in front of a customer and then not send it back, or, and not kill somebody, those kind of things. And to be a viable product, right? Because, if you're out there, you're in an industry, you're doing this for a living, you want to be able to make money. So I've seen a lot of companies fail at the hardware. They got great software ideas, and their system's great product idea, but then the hardware just falls apart. It's tough to get the hardware. Okay, so to give you a little background, I'm Director of Hardware Engineering at Brew Robotics Automation. Zebra Robotics, you may be more familiar with Fetch Robotics. Fetch Robotics was acquired by Zebra in August 2021. It's had its own kind of ups and downs along the way. I feel like it's pretty solid at this point. But it wasn't easy. There was a lot of challenges associated with it. I might even towards the end of the presentation, if we have time, I'll talk about some of the kind of hiccups you can have on that kind of path. I've been in both the industrial and kind of the commercial grade residential robotics, just like Camp. Camp and I were at Nito Robotics. It was a fun job. That was, it's rad. Avi was there. It was a good job. You got to work on cool robots, and there wasn't as much in terms of all regulatory and functional safety stuff you had to deal with. Just had to make it work right. And then, we got to explore different ideas in the product design group. I started Nito as a senior mechanical engineer, and then I eventually worked into my role as the director of product design. That was an interesting journey, and they were also acquired by a German company called Ford. So there, I can probably relate to some things about acquisitions at this point. I've been through 2 of them. I see a lot of parallels every time. It's a lot of repeating stories in these acquisition steps. So anyways, let's go into what I'm really here to talk about. Industrial grade robotics. So like I said, I started out at Nito and Valley. It was a tough break, or it's tough for me to break into the robotics world because I had actually spent from like 2013 or so in aerospace and avionics. And, I had the opportunity to do some other stuff along the way, but basically that's what my resume read. And so when I was trying to get into a robotics company, it's challenging, but, they gave me a shot. And a lot of it was based on some of my extracurricular activities, which we talked about. After a 5-year stint at Nito, I went on to Fetch. That's when all the founders were still there, except for Bergs. Bellamy was CEO, and it was still like a very kind of like startup-y culture, very fast-moving. Worked a lot of hours to get it done, whatever it took. Also, like I said, I had a tough time breaking into the robotics industry, but one thing that helped me was things like this, right? One hobby robots. Getting a feel for it, having a passion for it, and that thing for me was bad ones. Okay, so I've already talked about this. These are the type of robots I'm going to work on. Some of them are rather large. 1500 is just like it sounds like, 1500 kilogram payload. The smaller robots are all common bases. Whether it's the Core Connect or the H9 shell, we have other ones like the Flex shell is probably the most popular seller right now, which is a fulfillment accessory. But they all carry uses common base. Boom. Okay. Anyways, the use of common base, in functional safety world, it's called a type A base. Type A base is just a base with nothing on it. And then you put the accessory on it, whatever that accessory is. So anyways, these robots all use common base. Similar idea was for what we're going to do for the big robots, but for the most part, the big robots just use let them be with the cart that we're seeing, the big robot, it's a more common configuration that lifts pallets. Yeah, what do you got?
Are big robots autonomic or no?
Oh, you're talking like
They can't be
already translate. This is just a simple 2-wheel design.
Okay, they're all full.
2-wheel, all of them are 2-wheel. That's a good point. All of them are 2-wheel drive. And then I just use casters. You're not balancing robots. So that's what I've been doing for roughly the past 5 years. I started with them in 2019. I hit my 5-year anniversary in April. Okay, this is where we were. Nito, myself, Abby, Raph. We were at Nito. I think Raph, you might have been there before me. I started in 2013. It's still very early days. And that, you know, when I was looking around for robotics companies, there wasn't a lot back then. At least commercial ones that you could do full time, you know, maybe. There might have been industrial robots, and usually people refer to industrial robots as industrial arms, you know, other types of manufacturing automation. But there wasn't a lot of mobile robots back then, right? So I was pretty lucky to kind of fall into this one. I worked pretty hard for it. I had to move up from Los Angeles to the Bay Area to be able to take this job. Like I said, it was a lot of fun. Early days of robotics, you know, coming to the robot meetings, robot clubs, and working in that environment where we got to explore different ideas. But you know, the thing with the residential robots is you didn't have to worry as much about, and at least I didn't. You know, it's surprising to me once I got into the industrial automation space how important it was. In the residential commercial space, we didn't do risk assessment, right? Functional safety stuff. It's kind of like, we just kind of winged it. We knew we needed to do certain things like drop sensors, but we didn't necessarily like put together a formal like risk assessment with, you know, performance levels and, you know, have third parties look at it and get any kind of like CE marks or anything like those. Okay, so a little more about my background and how I got started. I'm a hardware guy, like I said. Started very early with hardware, although I always knew I wanted to do robotics. You know, I could have done automotive racing or whatever, but I knew early on, mid-90s or so, that I wanted to be in robotics. I studied, you know, spent a good amount of time studying robotics at the University of Florida for my undergrad. And, you know, early days, it was Robot Wars, right? 94 to 97, Robot Wars. And that's what really got me inspired to, you know, do robotics and then kind of follow that path.
I remember when you took a chunk of cement out of the dumpster cinder block.
Oh, yeah, I did that plenty of places. Wish it would have been a lot more effective in the BattleBots arena. Definitely was really effective against concrete blocks.
We've all taken chunks of cement out of various things.
Yeah. So here's one thing. Here's a fun fact. Camp PV is the only robot fighting competitor that I know of, at least, that has ever won an autonomous fight with a robot.
Thank you, thank you. The older I get, the better I was.
With that was 97, right?
96. I got thwacked in 97 by the same guy, Bob Gross. But the good thing about being in the autonomous division, you're one of two, so you automatically make it to the finals.
That's great. So that was my original inspiration, was to do an autonomous fighting robot, but I realized how impractical that was going to be, so I stuck to radio control. Anyways, for those of you who aren't familiar, this is Ghost Raptor. Ghost Raptor competed in 2015, 16, 2020, and 2021. Didn't have a great run. Much earlier on in my career, I got to run with smaller robots, but this was a fun robot to work on. And a lot of this was based on the work that I did for this robot, which was called Predator, which competed in a number of robo games and then also appeared on a number of TV spots. Two of my favorites were, this was Disney Lab Maps. And the bottom one was way back in 2002. The first commercial after Super Bowl kickoff was a Bud Light commercial called Robo-Bash. I don't know if anybody ever remembers that one. But this robot was based on, this robot was based on those jaws, which was based on another robot that I had built called Triploraptor. That just kind of like all mix and match pieces. You can actually see elements of, here, make sure of this. You can see elements of Predaraptor and Ghost Raptor because I used the same chassis. So those chassis pieces were pieces that I originally built back in 2009, and then for this robot, and then I just hacked them into Ghost Raptor, and I kept using them because I'm lazy. It's hard to build robots and expensive. Okay. So the money thing, we talked about that a little bit. So I was struggling in LA. I was living in LA. I was trying to find a way to get into business, and I had a couple opportunities. This one was from Lenovo. I built some robots, or at least some setups for them where they could do autonomous driving through a touchscreen, or just actually not autonomous, manual driving through a touchscreen. And that was a good way to make money, but it wasn't a living. Also dabbled in exoskeletons, and this one you might remember from Comedy Central back once. This was Gamma Raptor, and this is 24 years ago or something. Okay, let's get to what we're here to talk about today. Oh, by the way, this is you might recognize one of the members in the audience here. This is Sarat. Okay, so Sarat is over there. I'll say it. So Sarat is over there doing the disparity map calibration for the stereoscopic stand camera on the top of the robot. This is one of the NASA sample return robots. If anybody's familiar with that, they have the Centennial challenges, and they have like the Regolith challenge, it's a sample return challenge. They also have the subterranean challenge. Anyways, yeah, we had a lot of long nights working on this thing. Worked pretty well. We had a lot of fun. Nod your head down, Sarat. Okay, yeah, that was a fun one. Okay, let's get down to brass tacks. So, industrial grade, what does that mean really? You can call it whatever you want. It could be a poor design or a great design. But whatever the case, you're going to sell into, if you're going to sell it out into the world and let it go out into the wild, you got to conform to a couple different kind of standards, directives. If you're selling in Europe, kind of a different level of liability as opposed to selling in the States. Whatever the case, usually you want to use some of these as, maybe a first stop, especially if you're working with like warehouse automation type of robotics. This is going to apply, most of this is going to apply to anything you put into, warehouse automation, like in the States. Switching power supplies, the United States standard for that. You also, need a low voltage directives, anything under 60 volts. You're going to have, a certain set of standards. Anything above that is considered more dangerous. Different standards. So for us, simply the thing we got to worry about the most, my job, as director of hardware engineering, I'm kind of the gate for not all the design work, but I'm the gate for the thing that's going to keep us safe, right? I have to make sure we don't put out anything in the world that's not going to electrocute somebody, it's ground bonded and it's high pot testing on it, and then functional safety, this kind of thing. So it sounds like a glamorous job.
Chuck? Chuck,
yeah.
can we get the microphone a little closer?
Okay, where is the microphone? Just gonna come. Okay. Dan's gonna help. Okay.
How's that for video?
Is that better?
Yeah, go ahead. Sorry.
Is that better? Okay. Other thing we need to worry about is can't screw up everybody else in the environment we're in. You also have to conform to the 15B, the FCC, for radiated emissions. Typically, and it sounds counterintuitive, but they actually have a stricter standard for the residential than you do industrial environments. Usually they're a little more, the margins are lower for industrial environments than they are for residential. Usually everybody who's producing something though should be perfect. And then there's harmonized standards in the European Union as well. So the UN standard would be harmonized with the FCC. Okay. Some of this is really boring. I get it. I think what maybe this is useful is if you ever have to go into a situation where you have to talk through, okay, what's the scope of the work we got to do to get this thing into a product? Here are the things, here are the steps. Here are the functional safety steps, and here are the relevant standards. Here's the stuff I tend to look at way too much. Risk assessment standards are like on top there. You've got the NCD 11.0, the ISO 12,000. I think I got that wrong, 12,100. Anyways, the 13849 is like the Bible for safety related parts of control systems, which is maybe most relevant for what most folks are doing in here, right? It's if you look at that standard, you can see all the parallels with, okay, well, if you're doing embedded software, if you're doing application software, or if you're pulling out, you're doing block programming, or if you're using discrete components to do your logic, right, in your system. Usually you would look at the 13849. The 10218 applies to industrial arms. Maybe it's relevant, maybe it's not. I mean, if you have a mobile manipulator where you have a base and you've got a manipulator on top and you're going to go do picking, or you're going to move a workpiece from one station to the next, you're going to have to look at the 10218. And basically what the 10218 does, it says a type C standard. It's a very specific standard. You can see type A standards, type B standards, type C standards. Type A are very broad, type C are very narrow to a specific function. So the type C standard for the 10218 is specific to industrial robot arms. The thing that you guys might be interested in most, and that Melanie Wines actually kind of pioneered, is the R1508 -1, which is for industrial mobile robots. So the -1 is for the manufacturers. That's the standard for the manufacturers, for the people who actually design and build the bases. -2 is for the system integrators who take the bases and build something on top of it and put it in an environment. So, and usually what, you get one of these type C standards, the things that it adds, I mean, you're doing a risk assessment, like here, for any machine. This would be any control system that's going to be on those machines. Doesn't have to be a robot. But then this is specific to the mobile bases. And what it does, it imposes additional requirements. And it also outlines additional hazards that you have to add to your risk assessment. So that's kind of this would be a type. This would be but these type of things, type C, right? Industrial robot arms and arms. And then this is what we're hoping to harmonize with the R1508 is 3691-4. I actually sit on this committee, and I sit on the committee that's trying to harmonize with the European group, which is a challenge. Say that it is. Anyways, okay, like I said, these are risk assessment standards. Type C standard, this is a risk assessment, very specific for industrial robots. And it is, you know, this is a lot more restrictive and conservative. This is very broad. This one, it is actually more challenging, you know, to do risk assessment based on this. Some people kind of cherry pick which one's easier. And sometimes you'll get customers in my world who very specifically ask for, we want the risk assessment done this way, right? Okay, once you get through all that, then you put your safeguards in place. You kind of do this loop with the safety-related parts control system for Q29. And then if there's any residual risk after you put in your safeguards would be LiDAR, right? LiDAR with a protective zone, would be cameras not quite as reliable, you know, in terms of the, you know, the safety rated level as LiDAR, but you can still use them. It's, you can prove out that you've gone proper monitoring of that camera. And then, you know, once you've gone through that, put all your safeguards in place, you're gonna, you know, have some residual risk. And then you kind of resign that risk by putting administrative controls in place. That's like training, or that is like bolstering, make sure this thing doesn't go over a stairwell or off a loading dock, that, other things like that. That's what that world looks like now. Here's the eye chart. And I wanted to give you guys a cheat sheet. Anybody online seeing this? There should be.
Yes.
There we go. There we go. Okay. All right. This was a hack together last minute, kind of. I wanted to give you something. If you're effectively, if you're ever going to go through a functional safety exercise, right? You're doing a risk assessment, then you're trying to establish what the risk level is, and you know, finally, you know, figure out what your PL level is, and then figure out, you know, what your PL performance level required is, and then what your performance level achieved is. And that's going to be where the, you know, disconnect happens. You have to prove that your system, once you figure out, you know, based on risk assessment, what the risk is, right? And there's different ways to do it. Like I said, the PT306 was most prescriptive. You know, you go through these steps, and you're like, okay, what's the injury severity, what's the exposure, what's the possibility of avoidance, and then you go through this kind of like separate. I really don't like it.
So Chuck, people online can't see where you're pointing.
Oh, okay.
So if you could say, you know, about a month or something.
Yeah, okay, thanks. Okay, so top left is where you first do your risk assessment. All you're doing, basically, you're putting together task and hazards, right? What are your tasks, and let's say hazard association. You go through each one of them, choose a huge list. Once you've established that, then you go through this kind of stepwise approach of, okay, well, what's the injury severity for that specific task hazard? What's the exposure for that specific task hazard? What's the possibility of avoidance for that specific task hazard? You go through all that, and then you establish, okay, well, given that, what is our risk? And you see in the lower left, there's this kind of like, kind of spider, I don't even know how to describe that. It's like a spider web matrix or whatever, where you go through and each stage of this, you know, you choose a different level, and then eventually you end out on the right with the risk level there. It's the lower left graphic, and the risk level down at the bottom. You're going to see, okay, well, I'm either negligible, low, medium, high, low, high, whatever. But that's what you load into your risk assessment as the first iteration. Where are you putting the safeguard? Okay, well, once you've established that, then you know what to plan for. What you got to design. Because
what's an example of a risk? Like, let's do one of them in 10. What's the example of a risk?
Okay. Okay, here's the task. Task is, the robot is taking a fulfillment item to the pack out. Okay, transporting it. But the pack out area happens to have several. It's not covered, right? Yeah, there's no admin control yet. Let's safeguard that.
It's kind of hard to hear you guys online.
Yeah, what is the risk, of that, right? Your task hazard is taking it to a pack out area where there's a stairwell. Okay, well, I mean, if we say, okay, well, if somebody's walking up that stairwell, what's the severity of the injury? It'd be significant, right? Especially if, it's a 167 kilogram robot. It rolls down the stairwell. What could that do? It's relevant, right? It's like, and that's considered moderate injury. There could be even worse, right? But that's you're gonna get, yeah. That's and they specifically in the R15-306 they line out. Okay, what are they? Is there amputation? Like a little tiny tip of your finger amputation? That's considered a moderate injury. If you're in the hospital, requires a hospital stay of like a day or so, that's a moderate injury. Severe injuries are like multi-week injury, right? It's like you're going to be out of work, could be permanent damage, like amputated arm, whatever. So it keeps stepping up. And that's how you make this decision, right? Now, there could be potentially a really severe injury, but the chances of it happening are really low because your exposure is low and you can easily avoid it. And a lot of this is judgment calls, but you could easily avoid it. And then maybe the risk is relatively low. And that's kind of the stepwise process you go through to kind of come to, okay, well, this is medium risk. And once you get to a medium risk, then you have to go to the next step. It's okay, well, before we have any of that admin controls, or before we have any safeguards, we go up here, and we got this little matrix in the upper right. If you look in the upper right, you can see you got negligible, low, medium, and high, and then you got a PL. It's a PLR, which is performance level required. And you're going to see these B, C, D, E, E. There's an equivalent in European standards called SIL, right? And you can map out. But whatever the case, performance level, basically, what does your safety-related parts control system have to perform to each performance level, right? In order to meet, the safety requirement of the system, right? To reduce the risk enough for it to be used.
Get the microphone closer.
Here.
Okay.
Okay. That's what I'm gonna do. Should I just hold it?
Yeah, maybe we'll get lapel mics for the future.
Okay, so we're most of the way through this. We're almost there. The other thing you got to concern yourself with, and as a hardware person, this is something I look at, is okay, what type of system do you have? What category system? And there's like category B, 1, 2, 3, it's category 4 as well. I'm not showing those, but the ones you might most be familiar with is, okay, well, if you've got error handling in your system, even if your compute logic is the same as your test equipment, right? It's basically, consolidated into one processor. You can still claim category 2, or you could have your logic external to your test equipment. And those are the different architectures of the system. Category 3 is basically redundant systems, and they're cross-checking each other, right? And based on how you went through your functional safety, determine what your required PL level is, you might say, okay, well, I need to be PLD, but I also need to be category 3, right? So I have to have a redundant system that's cross-checking.
So that would be 2 towards cross-checking everything.
Basically, yeah. Identical systems.
That's in addition to the ports themselves, like PCC memory for something to critical.
Yeah. Yeah.
Memory to one word PCC memory still works.
Yeah. And then, yeah, and you can,
Why?
category 1 does not have any test equipment or output of test equipment. Test equipment would just be something that's checking. It's just like a check. It's like an error check.
That's not in the machine itself, not in the fact, not a test equipment.
Right. It can take different forms, but it can be like right within the same logic system, like motherboard, right? I mean, it could be just one more loop that's doing fault detection, right?
Seems like a fault detection would be here.
Yeah. A lot of this stuff came from back in the day when you were doing like PLCs, and then you might have something that was doing like an external check just to double check nothing was going haywire.
You know, this, the ultimate driver for this is UL or NTRL and OSIP, right?
Yeah, that's right.
It's all
Yeah.
driven by, so they drive this functional safety.
They have very broad kind of requirements for what a employer has to, you know, deploy into an environment in order to keep workers safe. It's very broad. It gets a lot narrower when you're talking about ANSI, ISO, IEC, right? And UL.
In the United States, we have to comply with these, like, could I release some batch size mobile without functional safety in the United States?
Yes.
Yes, I can.
Yes, but then it's a huge liability, right?
Yeah, so it's a liability.
Yeah.
So set up 20 shell corporations before you do.
Well, it'll be hard to sell into companies that are willing to pay for it, right?
Companies that know what they're doing. But
Yeah.
like some random company that's never part of the.
Absolutely. The states are different, right? European Union, you have like mandates, right? You can get thrown in jail if you don't conform to certain like functional safety.
So you don't have ISO standards. You don't do the ISO standards or functional safety, and you don't do it. You do it.
Potentially, yeah. I don't know all the details of that because, you know, haven't violated any of that, but
Sure.
but you get the gist. It's like the US is a lot more kind of like you just kind of do it at your own risk, you do your own due diligence, and then you know you release a product, right? Yeah. And then the lawyers get involved in the US, right? Sure. Okay. Anyways, so you get to this point, again, we're only at the performance level required. Then you put in your safeguards and your protective measures, right? Safeguards would be like the cameras and LiDARs. You know, there's other things you could do. And then the protective measures would be like administrative controls. I mean, that's a very broad.
Protective measures, we require all employees to be trained not to, touch the exposed conducts.
Yeah, that's one of them, many, yeah. Or it could just be, okay, we require you to wear like steel toe shoes. Something like that. Steel toe shoes, right? Or it could be, we're gonna block off this portion so the robot doesn't, you know, mislocalize and go into, you know, the wrong part of the warehouse. Things like that. So you've gone through all that, and then the last part of it is you have to prove what your achieved performance level is. So you've gone through all these steps, you figured out what your required performance level is, and then you get down to the, you know, the final, like, okay, well, this is what our hardware is doing, this is our test rate, this is the demand rate, this is like the diagnostic coverage, this is the mean time to failure of the hardware components. A lot of nitty-gritty stuff happens down at the bottom right here. That's where I spent a lot of my life trying to prove, hey, I know what the risk assessment said. Is our robot capable of that, right? Any questions? Because this is kind of the meat, and functional safety is not an easy thing, but I feel like, you know, if you have a little cheat sheet, you can kind of get your head around it a lot easier, and that's what I meant to put together here.
Did your fighting robots pass all these tests?
No, it's really ironic. I built robots. They're basically really dangerous. 90% of my life, and now I'm stuck in the functional safety world. That's great. All right. Fun. It can be, it's interesting to dig into like the system kind of level performance. I mean, it can be rewarding. And if anybody is actually interested in functional safety, I can tell you in the Valley, you would be in high demand because there's not a lot of functional safety experts in the Valley. Usually they're in Ohio, right? They're in, Washington or somewhere else, but they're not in the Valley. And it's hard to get like good coverage from, believe me, if I had my choice, I'd hire somebody to do this functional safety, but I get stuck with it a lot.
Chuck, you're director of hardware, right?
That's correct.
Is hardware, is that electronics or mechanical?
That is everything. That's that actually covers mechanical, product design, electrical, a little bit of firmware. Okay. So I get to dig into a lot of really cool things. It can be, yeah. I mean, it's like the CAN bus that's talking to the drives, talking to the charge base, talking to the batteries, all these things. I mean, there's the nav part of that, right? Where you're putting together drivers for base controllers and things like that. And then there's things that, those are things I don't touch usually, but I touch I see all the firmware that happens on like our main boards, that are triggering breakers and things like this. Commercial, probably very similar. I'm going to say probably only because I've never had to really dig into it. I know I've seen functional safety standards for robot vacuums. They exist. A lot of the dangers actually exist in, residential grade that don't necessarily exist in industrial grade, but, there is a lot of overlap. We would see things, and if you're not careful about, for instance, your electrical safety, right? You got a charge base in a house with carpet. Now, if you're an industrial robot, you're in a concrete warehouse with a lot of steel. So there's that certain level of liability that goes along with we're putting something in somebody's house and it plugs into the mains, it plugs into the wall and gets 120 off of it. There's a danger there. I would suggest, if you're going to design that kind of product, you do your due diligence around, okay, well, what does it take to do that really safely? Functional safety, I mean, we did, now that NITO is officially out of business, we can say that.
Have you heard of Nexero?
Huh?
Have you heard of Nexero?
Xero?
Nexero?
Oh, Nexero, yeah. That's like the fat version of NITO, right?
It's the NITO XV. It's come back bigger and better.
Yeah.
Commercial vacuum cleaner. Vorvik has started a commercial startup. So NITO lives on.
It does. A lot of the industrial design we did for the next gen NITO lived on as well. That was refreshing. That survived at Warwick. Okay, so whatever the case, the things that we would see for functional safety in residential robots, of course, was a kamikaze robot off the top, deck of the stairs. Sometimes off the top deck of, you see these kind of lofted kind of apartments or houses, whatever, where they have, a top deck and it's got a little gap into the rail, and the robot would love to slip under there.
Were you there for Burning Base, Chuck?
For Burning Base?
Melted butt?
Yeah, I was with the 10 whiskers. So there would be situations like, yeah, there would be situations like based on the material that you had on the charge plates and the charger on the robot, or the charge plates on the robot, charge plates on the charge base, you would get these little kind of 10 whiskers that would come up.
Schmutz, I think is the technical term.
Schmutz. And then it would go full on, okay, let's start charging. And then it would just be a tiny little wire, right? I mean, it would be a little conductor, and then I would heat up, and then it would start melting things. We had a couple instances of those before we finally fixed the problem.
And that's why you have the Nito waggle when it gets to the base charging base. It's wiping the connection.
It wasn't trying to be cute, it was trying to wipe it off, right? Okay. For the most part, that's it. I just had some parting kind of thoughts. This is general, like, things I've learned over the years, developing products for robots. Just one functional safety failure. I mean, a big one. Smaller ones, we managed to we dodged the bullet a couple times at Nito, I think. It's been a little more stable at Fetch, Zebra. I haven't seen anything that's like really scared me. But just one functional safety failure will sink, especially a startup. I mean, if you're starting a new company, and I don't know if anybody aspires to do that, but if you're doing that, you got to really, really be, wary of something like that happening. Reliability problems will sink you. We saw it at Nito, and I saw it at Fetch. We've kind of reined it in a little bit, but sometimes by the time you rein it in, it's almost too late. And if you don't think about it early enough, you've already developed a reputation with your customers, and you've lost them. So, similar kind of vein, quality problems will sink you.
Standards are in order, like several orders of magnitude higher than you would expect. You have to sit down and calculate the numbers, and get something. I parroted my slide from a couple months ago. 1 second, 1 in a million chance, it fails every 2 weeks.
That's right. If it can fail, it will. That's right. Some other things again, I'll send this out if you guys want to see it, but too much inventory will sink you, especially when you're in tight kind of cash margin businesses. Irrational demand plans, which couple with too much inventory. Only having 1 or 2 customers, Bossa Nova. Over investing in the latest, hottest thing. I look at the Anki kind of storyline. I'm like, wow, what a great company that was. And then I kind of think about, well, where did they go wrong? And maybe I don't fully understand it, but I always felt like, okay, well, maybe they were putting too much.
Who are you talking about? Anki?
Anki.
Oh yeah. Nito North.
That was Nito North. I don't think I fully understand that, so I don't necessarily want to throw shade on them at all. Okay, so not properly embedding your contract manufacturers, thank you. That if anybody's ever heard of Ecovacs, anybody know Ecovacs? Ecovacs, prior to being Ecovacs, was Nito's first contract manufacturer. And after we moved on, because Nito would do that a lot, they'd move on from one contract manufacturer to another, because the terms weren't good, or we weren't getting the service we wanted, or the volumes weren't high enough, and so that the things just weren't work out, so that we move on. But what we found was, our first contract manufacturer actually came out with their own robot, vacuum robot. We did a tear down, opened it up. They actually had our PCBAs in there with our part numbers, selling it, in the Asian marketplace. Now they're bigger than iRobot, right? In terms of like their volumes. Anyways, interesting backstory. Expanding into too many countries will sink you, and robots are really hard. That's I guess the take-home thing. Robots are really hard. You got to get it all right. It's probably best to, if you're ever going to start a company, I don't know if there's anybody that's got that in their head, but make sure you partner up with folks, right? Don't try to do everything yourself. It's really hard to do it all yourself. All right, well, that's about it. You guys got any questions?
Thank you very much, Chuck. That was awesome.
Yeah, I mean, I'm sorry it wasn't a little more polished, but
No,
we're
perfect.
interested in what I could offer. So,
Yeah, that Ecofax guy, I think he showed up some afternoon with a big briefcase full of money.
Are there any questions from anybody online?
That's what a comment. I had the pleasure of sitting beside a fellow that had worked as the one of the business people in Atari. And I asked him, I said, what happened to Atari? And he said, well, when we came out with the Atari 800, we didn't realize we were building a hula hoop. He said we had warehouses full of Atari 800s that we couldn't pedal. That fundamentally cycled. So it follows right what you just said.
But they made too many of them?
Yeah, they had, well, you can imagine the inventory problem they had. You know, this will cause you all kinds of problems. Anyway, nobody was buying them.
Yeah,
So,
it's a pretty common theme. I think another one of my favorites, and I forget the name of the computer company, and it's like something they teach in business school. That if you announce your product too soon, right? So you've got a demand for your existing product.
That's Osborne.
Yeah, Osborne, exactly. Yeah. So Osborne Computer, they were on top of the world. They were doing great, massive sales. And then they announced their new computer probably about 10 months before they were ready to release. Well, then nobody bought their existing computer. And then they built up all this inventory. They never even made it to the release. 10 months later, only 10 months of the actual follow-on model. And that's something, we always, concern ourselves with at Zebra, because it's like, well, yeah, we got stuff in the pipeline, but don't talk about it too much. We want to get utilization, add value to the thing we have today. So
very fine. Anything else? Any more questions out there?
Just another quick comment. I worked for Hewlett Packard for many years in the data systems division with the 2115, 16 computers, 2100. And that was one of our biggest problems, is keeping the salesman not, from telling the customers about the latest and greatest one. And it was really difficult to keep them to get their mouths shut.
Yeah, because nobody wants to buy an outdated product, right?
Absolutely.
In the industrial automation space, that's even a problem. Good thing, the one thing that can save you a little bit is RAS, because you can do robots as a service and just basically eliminate any kind of risk that the customer's going to see by telling them, hey, you got this, and then we get the latest thing when it comes out.
I used to work for Androbot. You ever hear of Androbot?
Mm-hmm.
Our biggest problem was, I think, the CEO.
That would be Nolan Bushnell, wouldn't it?
We won't say the N word.
Yeah.
Oh, Nolan. Yeah.
He's down
All right.
here now, supposedly.
All right, what else? Any more questions for Chuck? Chuck, thank you very much for the presentation. It was awesome.
I have a question really quick. I have a question really quick.
Go ahead, Dillo.
Is there a particular order in which you would do things if you had to do it again? Like start with the power or start with this thing or that thing because that particular regulatory process takes longer, or it will take just, this much more engineering to do? Is there, when you're doing a product, is there a kind of a particular order of operations that you would attack?
You're probably going to convert to a design for your charge solution first, and anything that's plugging into the wall, and you're going to manufacture it, that's going to take the longest to get through either your UL or your TUV, right? So if you have a TUV mark in your system, They have to they gotta vet the design, you gotta test the design, you gotta test your manufacturing process, and then do quality in the manufacturing process. And that there's a lot of lead time to that. So those kind of things you want to get out of the way first. There's certain things you want to push off as long as you can, so you can test as much as you can before you commit to it. But you know, that's kind of specific to your product, and that's usually on board for a little bit.
All right. Thank you very much.
Thank you.
Hey, Sarath. All right. I want to thank everybody for coming out this evening, especially Chuck for doing the presentation. Next month is the HPRC Challenge Phase 2. So you are responsible for a presentation every month. Next month, I will be bugging you all week long. I make a motion, the meeting be adjourned. Do I have a second?
Second.
All in favor, say aye.
Aye.
Those opposed, say nay. Ayes
Aye.
have it. Adjourned. Thank you very much. Hey, Sarath, how you doing, buddy?
Guys later. See you
All
guys
right,
later.
man. Good to see you.
Yeah. Hey, Kim, it's
Yeah.
George.
Hey,
I've got
George.
something I want to clear up here. There's some confusion that seems like was resulted here. Let me remember in October, we had Hazel, right? This is the presentation. Okay. And now this, let's see, let me get it where she comes up. Notice this